welcome to your home school. This is your next session of your mathematics. So in this session, we are going to deal about the basic concepts of geometry. What is geometry, children? Geometry is derived from two Greek words, that is geo and metron. What is geo? Geo means earth, metron means measure or measurement. Combinedly, geometry is called as the measurement of earth. Where do we apply this geometry? In the word itself, we got measurement of earth. Geometry is important from thousands of years ago onwards. This practical application of geometry we are using. Some of the applications, where do we use this geometry? This geometry is used to find the areas or the areas of lands. It might be application of architecture, navigation purpose, and also it is applicable in astronomy. Before starting our geometry, some of the basic key concepts we are going to learn. What are those concepts here, children? By the way, what is a geometry? Geometry is one of the branch of mathematics. So we have seen till now algebra, arithmetic, geometry. Geometry is also one of the important branch of mathematics. So we start our concepts with a point. So can you see here, children, point? What is this? This is a point. So we used to hear a word. What is that? Mark a point on a line or mark a position in your graph. Okay, or mark a point in your map. Show your state or anything with a point you mark there and show. Right? So what is this point? It is a fine dot. Point is what? It is represented by a fine dot. Why do we use point? Point is just to show the position. Whereas point has no dimension, no length, no breadth, no width, and it doesn't have any weight or anything. So point is simply, it is used to show a position. Next, we are going to deal with a line. What is a line, children? A line, see here, you can see the endpoints with two arrow marks. What does this indicate? The line extends indefinitely. Line is extending indefinitely, either this side or this side. Okay, two ways it extends indefinitely and there is no end. So whereas it has no dimension, it has one dimension. What is that here, children? Length. What is a line? Line is a length or it is a breadthless line also, we can say this. Okay, line is having only one dimension and line never stops. Right? How do we represent the line? With the two letters, let me take here A, B. Arrowheads like this, you represent a line. AB. AB is a never ending line. It is extending indefinitely. So, if I mark a point here, how many points you can mark on this line? There are many points you can mark on a line. What are these points called as? Collinear points. What are these points, children, here? Collinear points. Why they are collinear? Why they are collinear? All the points lie on a same line. So those type of points are called as the collinear points. C, D, E, F, G. These are all the points which are marked on a same line. Those all the points are collinear. What is a ray? So look here. One point having an end means a line arises from one end point and it never ends. This arrow indicates it extends indefinitely. Okay, and there is no end for this line. Whereas one side is having an end point and another side it does not have any end point. So this is called as a ray. Okay, what is this, children? A ray is a line which arises from one end point. It has no direction. So any direction it can go. So this arrow indicates there is no end for this side, where this side having an end point. Suppose if I say AB, how do you represent this ray, children? AB, and one side arrow you have to show. Okay, how do you show a ray? AB is a ray, right? So let's see the line segment. What is the line segment here? Where it is having two endpoints. See here, there is an endpoint here A and there is another endpoint B. How do you write this, children? AB. Okay, how do you represent your line segment? AB is a line segment. Line segment is also one dimensional, having only length. Okay, so next coming to your angle. What is your angle here, children? Angle is nothing but it starts from one end point. Okay, there are two rays arising from same end point. This point we call it as a vertex. So two rays are arise from same end point, and here there is no ending and here also there is no end. It extends indefinitely. So these two rays make an angle here. What is this? Angle. So we have showed with an arrow mark here. This angle is nothing but it is the size of the angle. How it is measured? The angles are measured in degrees. It is represented by this. Okay. So now A, how do you call this one? B, C. Suppose let me take here. Angle is represented like this. Angle BAC. So there are many type of angles regarding with the measure. Okay, so all the types of angles we are going to learn, right? What are the angles and all? Next part we are going to see now. Just what is an angle? Same point, two rays arising from a same point or from the same vertex. Okay, then creates a measure of angle. So now let's see the plane. It can extend indefinitely. This plane, can you see the plane? I can extend this line more and I can extend this line. Means the plane can extend endlessly. Okay, where it does not have any thickness. What does it have? It have only length and breadth. Plane is a two-dimensional figure. So once again, point has no dimension, that is 0 dimension, and a line has 1 dimension, and whereas a plane has two-dimensional figure. So plane, it can extend indefinitely. So this edges, these lines we call it as a edges. This plane have 4 edges and 4 vertices, you can call this, right? So this is called as the surface. Okay, what is this here, children? This is a surface. That surface we call it as a area, right? This is a plane figure having 2 dimensions, and whereas this plane can extend indefinitely. 3-dimensional figure, it is a solid, it has size, shape, so length, breadth, height, weight, everything will be there. So let's see the 3-dimensional figure. Look here. So easy to draw here, children, like this, 2 boxes to draw, and you can join this. You got the 3-dimensional figure. So look here, this is length, this is breadth, and this is height. We have here 3 dimensions. So this solid is a 3-dimensional figure, and this can move from one place to another. 3-dimensional figure. Point is nothing, it is used to mark a position. Line is a 1 dimension, and plane is a 2 dimension. Solid shapes, this is a 3-dimensional figure. Children, did you follow what is the dimension? Length and breadth, length, breadth, height. Now I just want to show you all these concepts with an example here. See the point. I cannot show you any example. Okay, it is just to mark a point. It is a fine dot, right? It is used to show the position. Whereas a line is a one dimension, right? It is having only length, right? So now coming to your plane, you can extend indefinitely as said. So this surface is enclosed with the boundaries. That boundaries are always lines or edges, we said. So you can see a plain paper here. Can you see, children? This is an example for your plane. So plane having length and breadth, right? So look here, only this is a plane surface. It is enclosed with the lines, or it is called as the edges. So it is a two-dimensional plane. So now you can see here, children, this is a Rubik's cube. So what is this cube here? It is a three-dimensional. This is an example for three-dimensional. So how can you say here? Length, breadth and height. Length, breadth and height. It is a three-dimensional figure. Part of a plane. In this cube, I'll say, look here, only this, right? This, what you can see here, you can see only a square. So this is part of a plane. Only this surface. If I talk about only this surface, it is a plane. But total cube, if I talk, it is a solid. Okay. So how many plane figures are enclosed for this cube, children? 1, 2, 3, 4, 5, 6. Okay, 6 planes are enclosed by this solid. Let's see the angles here, children. This is your protractor, which is used to measure the angle. Let's start our angles with this. This is also one of the mathematical instruments, that is skywork. First, we start our types of angles with this. So observe here, this is the point. So observe here, children, this is the point, and from this point, two rays are overlapping on one another. So two rays are overlapping on one another. It doesn't create any angle. Does it create any angle? No. So this type of angle is called as a zero angle. What is this angle, children? Zero angle. Observe here, these two arrows are one above the other, which are fixed from one point. Okay, they are not moving any side. The two arms are emerging from the same point or on the same line, right? So now comes to your acute angle. Observe here carefully, your point is here, right? So now I have done, and it creates an angle. What is this angle? This type of angles, I call it as a acute angle. Why it is acute? So look here, same point, same, and two arms are all same. Then what happens? The measure of the angle, what it will be? It will be 0 less than x degree less than 90. That means this angle is more than 0. Understand the sentence here? It will be more than 0 degree and it is less than 90 degrees. Acute angle is always more than 0 and less than 90. It might be 5 degree, 10 degree, 18 degree, whatever it might be. This angle will be less than 90 and more than 0. All these angles we call them as acute angles. So see the next angle, children. So what did I do here? I made this two arms perpendicular to one another. Perpendicular to one another means this arm is perpendicular to this line. Perpendicular, what do you remember? 90 degrees, right? So look here, can you see this? So this angle is how much? 90 degrees. Okay, whereas here there is a condition, but here there is no condition. Okay, from here the angle is measured, the angle must be more than 0 and it will be less than 90. But here the angle is fixed. What is that fixed angle? That is right angle or 90 degrees. What is the right angle? The angle between the two arms is 90 degree. So next angle, what is the next angle? Look here children, little. What is this angle? You can see here, right? From 0 it is starting, acute it crossed, right angle it crossed. It's not perpendicular, 90 also finished. Then what is this type of angle called as? It is called as obtuse angle, right? So what is this angle here children? Look here, this is here obtuse angle. What is obtuse angle? The angle, suppose you may take anything here, y is equal to is more than 90 degree and y is less than 180 degrees. How can you write this condition here? That is 90 degrees less than y less than 180 degree. That means this angle is more than 90 and less than 180 degree. These type of angles are called as obtuse angles. So observe here children, once again let's come back. 0 angle, acute angle, right angle, obtuse angle, right? So now look here carefully, what am I doing? Yes, what is this? It is a straight angle, 0, acute, right, obtuse, finished. Now what is the angle it is created? That is called as straight angle. Vertex, two rays are emerging in opposite direction. One ray moving this side, another ray moving this side. This is called as a straight angle. Straight angle, what is its degree? That will be 180 degree. It will be fixed. So from here your angle starts and this angle will be 180 degree. What is your Z angle? Z is equal to 180 degree. So here X condition there. So let me take here P. Angle P is equal to 90 degree and whereas angle Z is equal to 180 degree you can say. And here Y angle is more than 90 less than 180. So now observe here. So now what am I doing here? Look here. Your angle started from here, right? Again say for me. Now, yes, 0, acute, right, obtuse, straight, right? What is the next angle? Now what am I doing? I'm rotating, right? So where is this arm started? From here it is revolving like this, right? It is creating an angle. One side it is acute, but don't consider this angle. You need to consider this angle. What type of an angle it is? It is called as a reflex angle. So observe here carefully. So a point, one arm is here, another arm rotated and then it came like this. So angle started from here to here, right? So angle is started from this point vertex to rotated and it creates an angle. What is this angle called as? What is this angle children? Reflex angle. Okay, so now, totally it has done one complete revolution and came like this. Then what is this type of an angle? Don't say 0. 0 is overlapping on one another. But after rotating completely, see here, from here this arrow moves like this. And again if it is overlapping, two arms are overlapping on one another. So if nothing, no direction there, it will be 0 degree. If I am showing any direction, can you see the direction here? The ray or the arm starts its angle from here to here, then it is overlapping on a same line, creates a complete angle. Okay, this arm rotated full complete one revolution it has done, right? So this type of angles are called as the complete angles, right? What is a complete angle? What it will be children? So let's take here M. Angle M is equal to 360 degree. Then whereas this angle, let's take N. Angle N is greater than 180 and less than 360. How can I write this? 180 degree is less than angle N less than 360 degree. Okay, let's recollect all the angles here. So there are two arms emerging from a common end point. It creates an angle 0, that is 0 angle. So now more than 0, less than 90, acute angle. So your angle is 90, then which type of an angle it is? Right angle, right? More than 90, less than 180. So which type of an angle is this? Obtuse angle, right? So now observe here carefully, what is this angle? More than 90 and it is 180 degree. Okay, it is a straight angle. So this is called as a straight angle. Okay, so next. Now what type of an angle is this? This is more than 180 and less than 360 degrees. So these type of angles are called as reflex angle. If it have done complete one revolution, then that is called as a complete angle. So once again, 0 degree, 0 angle, more than 0, less than 90, acute angle, 90 degree, right angle, more than 90, less than 180, it will be obtuse angle. And if it is 180 degree, straight angle, more than 180, less than 360, reflex angle. If the angle is 360 degree, then it is called as a complete angle. This is the instrument used to measure an angle, right? So look here, with this we are going to see now all the angles. And what is this? So observe here, this is 0. You can see two scales overlapping on one another. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Can you see here? Like this. Okay. So again another scale emerging from this side to this side. Right? So two scales are overlapping on one another. So observe here, from 0, if your angle you are seeing from here, this vertex should be placed here. Okay, from this line, this is 0 degree. So this is called as a 0 angle. If I place a point here and if I draw a ray, then this will be acute angle. If this is perpendicular, 90. More than 90, it is obtuse. Straight angle it is. If it is 180 degrees, it is straight angle. When you are measuring your angle from here, like this, you have kept your protractor. Suppose, if you need to measure an angle this side, there also you need to mark at the center itself, right? The vertex should be placed here, right? Now, you need to mark any 60 degree. From 0, you need to mark. Don't try to measure your angle from this side. Your ray is this side. So from this 0 you start measuring your angle. Okay. How you measure you need to observe carefully. So now this is 0. Then like this you keep here. What is the angle of this? Observe here children. It is 60 degree. It is acute. So now look here. It is 90 degree perpendicular. And then it is on the same line, it is 180 degree. So this is how much here children, like this measure your angle here. It is from here you need to see 0 to 140 degrees is the angle, that is more than 90, less than 180 degree. Like this you need to measure your angle with the protractor. What do you mean by collinear points? You have seen already. What are collinear points? The points, this is a line, right? So if you mark some points on this line, so how many points you can mark on this line? You can mark as many points you want, right? So all these points, so let's mark here A, B, C, D, E, F, G and your line X, Y, right? So how many points you can mark? Infinitely many points you can mark. But where are these points? All are lying on a same line, right? So these type of points are called as collinear points. What do you mean by this children? The points are all lying on a same line are called as a collinear points. What is its opposite? which doesn't lie on the same line, they are called as non-collinear points. So look here, are they lying on a same line? No. So therefore these type of points are called as non-collinear points. If you try to join, will it form a line? No. So these type of points are called as non-collinear points, and these are called as a collinear points. So complementary angles. What do you mean by complementary angles here, children? If the sum of any two angles. So let's take any angle, children. Angle A plus angle B is equal to how much? 90 degree. If the sum of any two angles is 90 degree, then those type of angles are called as complementary angles. So look here how they will be. So this is a 90 degree angle and this is a vertex, right? You all know. Suppose if one more ray is emerged from here, so what will be sum of this angle and this angle, children? It will be 90 degrees, right? So how can I write here? So let's write here A. This is B, C and D, a point here, okay? Somewhere a point on this ray. So now how do we write this? Angle BAC, this angle, plus angle CAD is equal to 90 degree. So what it might be? You may take here 20 degree, you may take here 70 degree. 70 degree plus 20, how much? 90 degree. The sum of the two angles or sum of the two angles is equal to 90 degree. Then these type of angles are called as complementary angles. And if the sum of the two angles is 180, those angles are called as supplementary angles. So same manner, let me draw a line here, children. So let me mark a point vertex here. Let this be another ray and this is another angle. So this might be 120 degree and this might be 60 degree. Right? So observe here 120 plus 60 will be how much? 180. Right? The sum of the two angles, if it is 180, then those type of angles are called as supplementary angles. So once again look here, children, if points are lying on a same line, those are called as collinear points. If they are not lying on a same line, non-collinear points. And if the sum of any two angles is 90 degree, they are called as complementary angles. And if the sum of any two angles is 180 degree, those are called as the supplementary angles. Same manner you can write A, B, C and D like that. You can say this angle plus this angle is equal to 180 degrees. L, M, N, P. So look here, angle MLP plus angle PLN is equal to how much here sum? 180 degree. So observe here, this angle 120, this angle 60. 120 plus 60 will be 180 degree. So if their sum of angles is 180, what is the type of angle? It is supplementary angles. So let's see the next one. Adjacent angles. What are adjacent angles here, children? Side by side angles. Okay, what are side by side angles? The two angles which are having only one common arm in between. That means, suppose this is, okay, this is a point, this is one angle, right? So another angle is like this there. So which type of an angle it is? It's not acute. More than 90. Then which type of an angle is this? From here, this is moving in this direction. So this type of angle is called as obtuse angle. So for this angle and this angle, observe here carefully. For this angle and this angle, what is a common arm? Common arm. This ray is for this also there and for this also there. Means if any two angles are having in between a common common arm, so we can say those two angles are adjacent to one another. So what you can say here, children? A, B, C, D. B is called the vertex. Angle ABC is adjacent to angle CBD. Angle ABC is adjacent to angle CBD. Suppose if I draw one more angle here, that makes E. So now look here. Is this angle is adjacent to this? No, it is not adjacent. Why? The two angles should have a common angle. Suppose if this is missing, then I can say this angle is adjacent to this angle. Okay, both the angles should have a common arm in between. Right, with example we'll see next. So let's see the linear pair. What is a linear pair, children? These two are non-common arms and this is a common arm, right? Suppose if these two non-common arms make a straight line, then those two angles are called as a linear pair. Let's see the lines, types of lines here, children. We are going to know this by taking a pair of lines. Pair means two, right? So types of lines we see here are intersecting lines, concurrent lines, coincident lines, parallel lines, and non-parallel lines. So first, when we talk about intersecting lines, so you remember, children, you know what is a line? Yes, there is no end for this and arrowheads indicates it extends indefinitely, right? So now I am showing here two lines where these two lines are passing through a common point, or that both the lines have one intersecting point, we say. These two lines meet at one point. That point we call it as a common point or intersecting point. So these two lines we call them as intersecting lines. Why intersecting? The two lines are intersecting at one common point. So now let's see the next lines. What is that? Concurrent lines. See here, concurrent lines. I am going to take more than two lines. 1, 2, 3, 4. Like this, what happens? So many lines are passing through the same point. Okay. So many lines are intersecting at one point. There is a common point for many lines. So those type of lines we call them as concurrent lines. What is this? Concurrent lines. Intersecting lines, and this is concurrent lines. Next, coming to coincident lines. What do you mean by coincidence, children, here? Suppose let me take a line here. Okay, suppose let this be AB line. If I say there is one more line CD, two lines, look here, two lines. One more small line, can you see here? CD, big line AB. The two lines are overlapping on one another. Two lines are lying on a same line, right? So two lines are there in a single line. That means we call those type of lines as coincident lines. So next, very important, parallel lines. What do you mean by parallel lines here, children? So let me draw two lines here. A, so let me mark here A, and this is B, and one more line if I draw C and D. And these two lines are having no common point. Whereas when we call these two lines a parallel, when these two lines are extended indefinitely without having any common point and they never meet, those type of lines are called as a parallel lines. So here, children, how do we represent parallel here? With an arrow mark again in between these two. So this line AB is parallel to CD. How do we write this? How do we say? AB parallel to CD. AB parallel to CD, or CD is parallel to AB. So now comes under non-parallel lines. What are non-parallel lines here? The two lines. Suppose look here carefully. So there are two lines. When extended, they may meet at one particular point. Means the two lines are going to intersect at one point. Then this type of lines are non-parallel lines. See here, these two are non-parallel, and here these are also non-parallel. Okay, so here what happens? These two lines when extended, they are not going to meet at any one common point. So if two lines are extended, they doesn't meet at any one point. There is no common meeting point, right? They extend indefinitely without meeting. So these two lines are parallel. These two lines, if extended, they too will meet at some place or some position. They are going to meet. Let's see here. Suppose this line is extended like this and this line is extended in this direction. They are going to meet at one point, forms an intersecting lines. Right? So these type of lines are called as a non-parallel lines. The intersecting lines, if two lines are having the same common meeting point, we call them as intersecting lines. More than two or three lines are having same common point, those we call it as a concurrent lines. And so two lines are overlapping on one another, those two we call it as coincident lines. And if they are not meeting at any point, those two lines are parallel. If they are meeting at after extending, if they meet at any position, then these two lines are non-parallel lines. Okay children, with this we are going to end our mathematics basics today. So we are going to meet in our next session with another mathematics basics. Thank you all.